Hello everyone, I am Chiranjeevi and welcome to this episode 4 of Rush series. In the previous episode, we have seen what data types are and what are the scalar data types, and we have seen different types of scalar data types. In this video, let's continue that topic and see what are the compound data types present in Rust. So let's get into this video. Hey, this is me again from the future. I just completed recording the video. So I just came back to tell that I also covered array indexing and tuple indexing and why the indexing starts from 0. So let's continue. Let's see what compound data types are. So a compound data type, as we discussed in the previous video, is a group of values or a collection of values. So this is nothing but a compound data type. So when you divide this group or collection into multiple values, those values become a scalar data type. So that's pretty much it about compound data types. And let's see, there are two compound data types in Rust. One is tuple and other one is array. These are the two compound data types present in Rust. Let's see what a tuple and an array is. Instead of knowing them separately, let's see them together because there are very slight differences between tuple and array, and let's see what are they, and this will make the process easier to understand the difference between tuple and array and what exactly are they. So basically both tuple and array are collection of items, as we have said before. So in tuple, the values can have different data types. So basically, let's say in your collection there are 10 values, and the 10 values can be related to different data types. So one can be an integer, and one can be a floating point number, and one can be a character, whatever. It can be any scalar data type that is present in Rust. So in array, the values must be of same data type. Values must be of same data type. So this is a major difference between a tuple and an array. An array can possess values from different data types, and an array can possess only the values from same data type. If you are using integers, you must use integers everywhere in an array. But in tuple, you can use any data type. So that's one difference. And the other difference is, this is not a difference. This is same in both tuple and array. They are immutable once created. So if you create a tuple and an array, you can't change the size, and you can't change the size. That's basically the immutability of the tuple and array. But there is something called immutability of values. Values are immutable in tuple. So basically, when you create a tuple, let's say you gave 5 values, and if you want to change any one of those values later in your program, you can't do that because the values inside tuple are also immutable. Along with the tuple is also immutable. So that's one thing. But in an array, the values are mutable. So basically, you have created an array. You can't change its size after that, but you can change the values inside that array in a program after you created it. So this is another difference between a tuple and an array. So how do you represent a tuple in your program? Using parentheses. So you give all those values that you want to give inside your tuple inside these parentheses, and you denote array in your program using square braces. So this is how you differentiate between a tuple and an array inside your program. So let's see how a tuple is going to look like with an example. So let's say I'm giving an integer to a floating point number 5.0 and a character C. This is perfectly valid in tuples because the tuples can have values with any data type. But in an array, it should be of same data type. Let's choose one thing. Let's say we want to store characters. Let's say A, B, C. So this is a tuple and this is an array. We have to specify which data type we are going to use when we are creating the array in Rust. So let's say the name of this tuple is, this entire tuple's name is tuple1, and the entire array name is arr1. We haven't gone through variables etc. in this series yet, but the next episode is going to be on variables and constants. So there is something difference in this Rust programming language regarding variables and constants, so that's why I have delayed it. And I thought it's more meaningful to know about variables after you know what are the data types that you can store inside those variables. So that's going to be the next episode. But let's say the name of this tuple for now is tuple1, and the name of this array is arr1. So how do you access one of these elements outside? So let's say you want to take out this 2 and you want to perform some operation. You can't change it because the values inside tuple are immutable, but you can perform some operation using this value. So how do you get that? To get this 2 out, you can use tuple 1, this denotation dot 0. So 0 will point to the first element inside the tuple, and if you want to access this last element, I mean the third element inside the tuple, you can access it using this denotation tuple 1 dot. If this is 0th, this is going to be first and this is going to be second. This is what we called index. The position is first position, but the index is 0 because the indexing starts with 0. So tuple 1 dot 2 because the index is 2, but the position is third. So this will give you ultimately the character C, and this will give you the integer 2. So this is how you access elements inside tuple. Remember, you can't modify these values because the values inside tuple are immutable. So it's similar in the case of arrays, but the denotation changes. If you want to access this thing A, you can access it using arr1 because it's inside arr1, and you can access it using this square brackets denotation. So you have specified the index is 0, so it's going to get this A. The indexing is similar to in the case of tuple. So starts with 0, 1, 2, but the position is 1, 2, 3. So if we specify index inside these square brackets as we specified here in case of tuple, so this will get this A. If you specify arr1 of 2, this will get this C. So ultimately this will result in A and this will result in C. This is how indexing works in both tuple and array. These are the major difference between tuple and array, and this is how the values are stored. As we have seen here, the position of that item is 1, but the index is 0. The position of item is 2, but the index is 1. Why the indexing starts with 0 in both the cases of tuple and array? Let's see why that indexing starts with 0. So let's take the example of an array. So let's say in our array all the elements are belonging to i32 data type, which means an integer of 32 bits. So as we know, 8 bits equal to 1 byte. So how many bytes does this i32 each value can take? It's going to be 32 divided by 8, which is 4 bytes. So each value of type i32 will take 4 bytes of memory. So in the memory, let's say we are storing this, let's say this array arr has these values 1, 2, 3. This is an array, and let's say in our memory has lot of bytes. Let's say if you have RAM of 8 GB, it will have many number of bytes. Let's say this is a very small part of that memory, not the entire memory, but just a very small part, and each of these box represents a byte. So each byte has an address. So basically, if you are living in a locality, how do you recognize your particular house? If you want to take a delivery, how do you tell that person that you are at a specific house? Using your house number. In a similar way, for each byte in this address will have each byte in this memory will have an address. So let's say there is a very huge memory, and this is a part of that memory, and let's say this particular box address is 1000. They won't actually be like these numbers, they will be in hexadecimal format, but let's assume for our simplicity that it is 1000. And what is going to be the address of this particular box? It is going to be 1001 because this is each byte. So this is going to be 1002 and so on. So let's say in the similar case, what is going to be the address of this particular box? It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10th. So this is going to be 1009. This address of this particular box is 1009. Let's say our array values are stored from here. So array is nothing but a collection of items, and those collection will stay together in the memory. So let's say in our case, the array has 1, 2, 3 elements. So those elements are stored together. But let's say this is i32 type. i32 type consists of 4 bytes. So which means that the 4 bytes from here together will consist of this 1. Let's take another color so you can see it clearly. So this entire 4 bytes will contain this 1. So the 2 will now be presented the next 4 bytes. So 2 will be present here in the next 4 bytes, and 3 will be present here in the next 4 bytes. So from here to here. So this is how an array is stored. So when you gave it a name ARR, it should point to some address in the memory. That's how variables work. So where is it pointing to? It will point to the address of first element in the array. So this will point to this address 1009. So when you go to 1009, what is the element you see? When you go to 1009, the element you see is 1, not the entire array. It's going to be 1. So when you want to see number 2, where you have to go? It's going to be 1009 plus 4 bytes, right? It's after 4 bytes from 1009. So it's going to be 1013, this point. When you want to see 3, you have to go furthermore 4 bytes. So it's going to be 1017, the address. So this is how the addressing works. But the name of the array will point to the first element's address. So when it is pointing to the first element address, when you want to access the second element, how do you do that? You will add +4, depending on the data type that you are using and its size, it's going to be that number. In this case, it's i32, so we will have to add +4 to get the second item. So ARR address is 1009, but 2 item address is 1013, which is going to be +4. So if you can see carefully what's happening here, when you specify ARR1, it is going to take the address of ARR, which is 1009, plus the number inside the indexing times the size of the each value. So in our case, it's i32 for each value, so it's going to be 4 bytes, which will lead to 1013, which is the address of second item. So if you give ARR of 2, it's going to be 1009 plus 2 times of 4, because each value is going to be 4 bytes, and this will lead to 1017, which is the address of the third item. That is the reason why the indexing starts with 0. If you take ARR of 0 now, what is it going to be? It's going to be 1009 plus 0 times 4, which will give 1009, which is the actual address of the first element. This is the reason why we use 0 indexing in arrays. Now this is fine. We know how to calculate the address depending on the index. In the arrays, each element is going to be of same data type. Here it is i32, and we are giving 4 everywhere. This looks fine. How can we do this same thing in case of tuples? In tuples, the data type can be anything. Each element can have different data type. How do we calculate the address exactly? So this is a valid question. So let's see how we can do that. So let's take an address, the same, a much bigger memory. So this is a much bigger memory than the previous example. So when you store a tuple with multiple data types, this is how it's going to happen. Let's say the address of this thing is 2001, and this is 200234, and this is 2005. So let's say you have stored a i32 value first in the tuple. Let's take our example in the previous case, which is 2, 5.0 and character C. This is our tuple. So when you store 2, it's going to be stored here. Let's say if it stores here, and let's say it's 5.0, which is F32 type. Let's say it also stored here, and the character C is going to take only 2 bytes, so it will be stored here. We can't say how many where the address of each item is going to be, because the memory which each type takes is different. So how does exactly tuples work? Tuple is not going to store things like this in a linear format, but what's going to happen is, let's say the address of this thing is 2020, this particular address, and let's say our tuple is started storing here. It won't exactly store the items itself, but what it does is it will store the address where the items are present. Let's say the 2 is present here at 2001. This will store 2001 here. So an address in Rust where the system is 64-bit, the address will take 8 bytes. So basically, if it starts from here, it will take 1, 2, 3, 4, 5, 6, 7, 8 up to here. So the address of one thing is going to take 8 bytes in 64-bit system. So this will take these many 8 bytes. So now it has to store 5.0, but it won't store that number, but it will store the address of that number. So it's going to be 2005 in this case. So it will store 1 2 3 4 5 6 7 8 up to here. Now see, it will take just 2 bits, but the address is still going to take 2009 address is still going to take 8 bytes. So this is how the tuple stores the values. So it will store only the addresses where the actual values are stored. So this will point to this particular value, and this will point to this particular value, and this will point to this particular value. This is how. Now if you see, let's say our tuple name is tup, and this will point to the first item's address. So let's say if you take tup of 1, it's going to take the initial value, which is 2020, plus 1 times the memory that is going to be stored by each address, which is 8 if it is a 64-bit system, depending on your system. So it's going to be 2028, which will be the address of this thing. So in case of tup 0, it's going to be 2020 plus 0 of 8, it's going to be 2020, which is the address of first element of the tuple. This is how tuple stores the values. It actually doesn't store the values itself in the linear format, but it stores the addresses, which will take the constant number of bytes in the memory. That's how indexing works in tuples. That's it for this video. Do let me know how you felt about this video in the comment section, and do like and share if you find this video useful, and subscribe for the future episodes of this Rush series. And in the next episode, we are going to discuss about variables, constants, and immutability. That's it for this video, and signing off.